Okay, so example number 5. You have two bikers, so there are two objects starting at rest some distance apart and traveling towards each other. So you have two bikers that are 400 meters apart, so we can call this guy number 1, and we can call this guy number 2, and they begin to pedal towards each other. So initially they're both going 0 meters per second. Okay? And then it says the first one is accelerating at a rate of 0.8 meters per second squared, and the second one, A2, at a rate of 0.6 meters per second squared. How long before they meet and how far has each traveled? So they're starting at the same time and they're eventually going to meet. So whatever the time is for one, that will also be the time for the other. So the times will be the same. The delta D for the first biker will be VI delta T plus 1/2 A1 delta T squared, but the VI goes to 0. And the delta D for the second bike will be VI delta T plus 1/2 A2 delta, whoops, the 1/2 didn't get in there though. 1/2 A2 delta T squared. And the VI goes to 0. But we can't solve either of these because we don't know the delta D's or the delta T's. But what do we know about the delta D's? We know that one of them travels part way and the other one travels part way, so that delta D1 plus delta D2 has to equal to 400 meters. So it's just like when you were doing word problems in math, you have to find the equation that connects them. Once you do that, then you can take what delta D1 is equal to and fill it in for it. So it becomes 1/2 A1 delta T1 squared plus, and what delta D2 is equal to, and fill it in where delta D2 is, 1/2 A2 delta T squared, and that's equal to 400 meters. Now, the only unknown you have is your time. If you want to get rid of the 1/2, you can multiply everything by 2. So A1 T squared plus A2 T squared will equal 800 meters. And then we need to solve for T, so you could factor it out. So pull the T squared out, and you would be left with A1 plus A2 is equal to 400, multiplied by 2 is equal to 800 meters, and then divide both sides by the A1 plus A2. So moving it up here, it would become T squared is equal to 800 meters over A1 plus A2. And now fill your numbers in. So 800 meters, A1 was 0.8 meters per second squared, and A2 is 0.6. So T squared is equal to 800 meters over 1.4 meters per second squared. Remember, that's going to give you T squared, and then you're going to have to take the square root. So divide by 1.4, and you get a T squared of, looks like 57. Take the square root, and I think you get 23.9. So delta T is equal to 23.90 seconds. Okay, question wants to know how long and how far has each traveled. So we go back over here now and we fill in for D1 into the 1/2 AT squared. So delta D1 is equal to 1/2 times that 0.8 and times the 23.9 seconds that we just found. So 23.9 seconds, and that gets squared. And then multiply it by 0.4, half of 0.8, 228. So you get 228.57 meters for D1. Then you go over here and do the same thing for D2. So delta D2 will equal 1/2 A2 T squared. So delta D2 will equal 1/2 0.6 meters per second squared times that 23.9 seconds squared. So that's going to be your time squared times 0.3, half of 0.6, and you end up getting 171.43. And you might notice that 171.43 plus 128.57 adds up to give you 400 meters, which means you did it right. Okay? So these are examples of the multiple step ones. Maybe let's just set up the next one and see if you can do it on your own. So the next one says, two cars are both traveling 14 meters per second, but one is 20 meters behind the other. Okay, so car 1, car 2. This distance is 20 meters. Okay, and it says they're both going 14 meters per second. So VI is 14 meters per second for the first one, and VI is 14 meters per second for the second one. The one behind decides to pass and accelerate, and they're going to accelerate at 4 meters per second squared. The one in front is nice. They don't accelerate. Okay, so they're actually going to let them pass. How long does it take the two cars to be side by side? So sometime later, car 2 will have moved this distance, and car 1 will have moved this distance. So please don't say that car 1 just has to move 20 meters to be side by side car 2. That would only be true if car 2 wasn't moving. But car 2 is moving, and so it's going to be somewhere up here, and that's so car 1 has to accelerate. So how are the delta D's connected? Delta D of number 1, if you look at the picture, should be equal to delta D of number 2 plus the 20 meters, right? This distance is equal to this plus the 20. So now we're going to do just like we did up above. You're going to get an expression for D1, VI delta T 1/2 A delta T squared. And you're going to get an expression for D2, which you could do as VI delta T 1/2 A delta T squared. But for this guy, there's no A. So it'll just be this. And now sub them in. So put this whole thing in where D1 is. VI delta T 1/2 A delta T squared. And over here it'll just be VI delta T plus 20 meters. And that might look awful, but remember the VI's are the same. So when you bring this VI over, it's going to be VI delta T minus VI delta T, and they're identical. They're going to cancel. The times are the same because however long it was taking car 1 to catch up to car 2, that's how long car 2 had to travel. And now all you have to do is solve for the time. So see if you can finish that one, okay? And we'll go over it tomorrow. So finish this one, and then on the free fall sheet, on the back of the free fall sheet, on the more kinematics sheet, this guy, more kinematics, please do 10, 11, 12 with early bird, bin Russian, and the jogger. And then on your displacement, velocity, time, acceleration sheet, do numbers 12, 14, and 15. Okay, so we're getting into tougher ones now. Even if you get stuck on one, move on to the other because they're all a little different. All right, and we'll see you tomorrow. Enjoy the rest of your day.